Inside of the MVC runtime, there is a component known as the display mode provider, and this provider maintains a list of iDisplay mode objects, and during a request, the runtime will ask each display mode object if it wants to handle the current request, and if so, that particular display mode object is given the opportunity to change all the file paths that are needed to satisfy the request. This is how the behavior we saw in the last clip is implemented. When a request arrived for our application, the runtime asked the mobile display mode object if it should be involved in the request, and when the browser was Opera Mobi, then the mobile display mode said, yes, this is a mobile browser, I want to go in and change things around. Then for each view that we used during the request, that mobile display mode object had the opportunity to render a view with a .mobile in the name instead of the default view. And that happened for the layout view, where we did have a mobile override, and also for the content view and any partial views that we used in the request, even though we didn't have mobile versions of those views. You can add your own display mode into the display mode provider, but keep in mind they are evaluated in order, so the first one that says it can handle a particular request gets the opportunity to do that. So you need to put custom display modes into the provider in the way that will work for your application. The block of code on the screen is very similar to what the MVC runtime would do. Sometime before application startup, it will add a new display mode to the display mode provider, which you can get to through the static instance property. In this case, the display mode is an instance of default display mode. It makes it very easy to work with all this. And that string parameter that you see in the constructor is a suffix that the display mode will use when it is looking for a view. So literally, does a version of the view exist at the right location with .mobile in the name? The other part of the default display mode to configure is the context condition. This is a predicate the runtime will check to see if the display mode wants to handle the current request. And what you see is a lambda expression that will return true if ASP.NET determine from the browser capabilities that the current browser is running on a mobile device. And again, that's all configured in the browser files, and the runtime looks at the user agent header sent in the request. But you can implement any type of logic inside of here and look anywhere in the request and return true or false if you want your display mode to jump in. Let's take a look and see how this works. The first thing I want to show you in Visual Studio is that I've added a new action to the home controller. The action is named Display Modes, and it's just going to walk up to the display mode provider, grab all of the existing display modes that are registered there, and hand those off as a view to render. Inside of the view, our model will be an IEnumerable of iDisplay mode. What we'll do is loop through each mode in the model, and for each mode we'll output its display ID, which is essentially a string identifier, and also the result of invoking the canHandleContext method. That is the method that the runtime calls when it wants to find out if a particular display mode wants to get involved in the request and start changing around file names or not. So we'll see a true or false result from that. And if we run it in Internet Explorer, we can see that there are two display modes registered by default in an MVC application. There's the mobile display mode, which returns false when the runtime asks it if it wants to handle this request. And that's the expected result because this is Internet Explorer, a desktop browser. And then there's a second display mode, which doesn't have a name. It's the default display mode, and it's essentially a no-op. It returns true every time, and you'll just end up with the regular default view when that display mode gets involved. So if you register your own custom display modes, you'd always want to make sure that they always come before this default display mode, or you remove that default display mode, because otherwise it will always return true and render the default view, and your custom display mode wouldn't be able to get involved. If we hit that same URL with Opera Mobile, you can see that the mobile display mode returns true. It gets to handle that request. And again, that's the expected result because this is a mobile browser. And now that we can see what display modes are registered and how they're behaving, let's add our own custom display modes. And that needs to happen during the application start event. So of course, we're inside of global.asax.cs where the application start event exists. And we'll call into add display modes to put our own custom display modes here. The first display mode provider that I'll register is another instance of default display mode that will use a suffix of mobile. And I'm doing this to demonstrate what you could do if there's a particular browser that you want it to use a mobile view, but ASP.NET doesn't think it's on a mobile device. So let's say that the browser on the iPad falls into that category. Well, this little bit of code will make sure that when a user requests something from your site using the browser on an iPad, this context condition will return true if the request header for user agent contains the word iPad, and if so, it will look for the suffix mobile in the views, and you can use mobile views whenever someone visits with an iPad. But let me add another default display mode to the provider to show you that we could also have silk views. So if someone is browsing from a Kindle Fire and we see that the user agent contains silk, then we could register a silk view instead of the regular view. And to show you how this works, let's do this. First, let's do a build and come into Internet Explorer and just refresh this page to make sure everything is registered properly. So there we can see it's not silk, it's not this other mobile display mode that's registered for iPad, and it's not a mobile view, so we're just going to use the default view. Perfect. And so if you want to test some of these other views from a non-mobile browser or a non-silk browser, well, most modern web browsers today will let you manipulate the user agent string that is sent to the server. That's typically somewhere in the developer tools or in the options. So I just pressed F12 to bring up the developer tools for Internet Explorer, and I want to change its user agent string to something that has silk in the name. That's not one of the built-in user agent strings here, so let me go to custom, and I'll give this a friendly name of silk and paste in the actual user agent string that is being used by Kindle Fires. And let me click add for that and also set it to use that user agent string. And now let's refresh and we can see that silk returns true. And that means that here where I have display modes, if I copy and paste this view, I should be able to create a display modes.silk and have that render instead of the default view whenever the user agent has silk in it. So let's open up that view and add something just to know that we're getting the right view. So perhaps up here in the body, add some text so we know we're rendering the proper view. Come back to Internet Explorer and refresh. And you can see we're getting the silk view because that particular display mode returned true. And now if I go back into the developer tools and change the user agent string to just be the default, and we'll refresh this again, we're not getting the silk view anymore. So this is what you can do with display modes. You can target your output to specific browsers if need be. And the context condition that you write receives essentially an HTTP context object, so you can look around at anything inside of the HTTP context, including things like server variables and cookies and the requests and so forth, to determine if you want to change what view is going to be rendered for the user. And I'll also point out that default display mode takes care of changing all the file names behind the scenes. So when we give it a suffix of silk and the context condition returns true, it's going to automatically go out and find something like displaymodes.silk and render that, or layout.silk.cshtml. But you can also drop down to the interface definition behind this object, which is iDisplayMode, and take even more control over how the actual file names are produced for the runtime to use. Another feature added to ASP.NET MVC4 is the feature that allows you to override the user agent string that the runtime will use when figuring out what display mode to select. This is done through a number of extension methods for the HTTP context object, and you can set or clear a user agent string for a given user session. Why is this useful? Because you might have someone looking at your site with a mobile browser, but they really would like to see the desktop version of your site because maybe their tablet is large enough to work with the desktop site comfortably. In that scenario, you could provide a link or a button that says, view the desktop version of the site, and when the user clicks the link, you'll override their browser for the remainder of their session, and they'll be looking at the desktop version of the site instead of getting the .mobile views. And of course, it can work in the other direction too. A desktop user could click on a link that says view the mobile version, and you can set them up to view the mobile site instead of the desktop site. And of course, when I say site, that's from a user's perspective. It might look like two different sites, the mobile site and the desktop site, but behind the scenes it's all one MVC application, just with different views being rendered. Let me show you an example. Inside of our display modes view, I've added a bit more output. I have a div that will output the user agent header sent from the browser. This is the HTTP context.request.userAgent value. And I'm also outputting the overridden user agent, and I can do that with the get overridden user agent extension method that's in the system.web.webpages namespace. If I look at this view in the browser now, then I'll see that the regular user agent and the overridden user agent are identical since I haven't done any overrides yet. And they're telling me that this is IE10 running on Windows NT 6.2, which most of us would call Windows 8, or maybe Windows Server 2012, but this is Windows 8. And you can see I've also added some buttons to the view that will post back to override the browser. So over here in the view, here's the form set up with the buttons inside that will submit one of the values of empty, mobile, desktop, or silk. And one of these values will get posted back to the home controller when the user clicks on them. So in the home controller, I have a display modes action that will respond to an HTTP post request, as opposed to the display modes action that responds to a GET request. But the post request will take one of those values and will have a crude but effective switch statement that switches on that incoming value and calls set overridden browser. Set overridden browser is an extension method for HTTP context, and that means in order to use it, you need to have a using for system.web.webpages. And there's two overloads of set overridden browser. There's one version that takes a browser override enum, so you can pass in browser override.mobile or browser override.desktop, and that's just a quick and easy way to set up either an Internet Explorer mobile user agent string for the browser or an Internet Explorer desktop version for the browser. That's what the .desktop would do. There's also a version of set overridden browser where you can pass in any user agent string that you want. So if the user requests that they want to see the silk views, the views that are customized for silk, then we'll set this up to have a user agent string just like the Kindle Fire, which has the word silk in it. And notice there's also an extension method clear overridden browser. And when the user clicks on the default button, that will clear out any override that's currently in effect. Let's give this a try in IE, and I'll first point out that we are using the default display mode. So we are looking at a desktop view. But if I click the mobile button, now my user agent header stays the same, of course, but the overridden value changes to look like IE mobile. And this allows the mobile display mode to kick in. So if we did have a .mobile version of this view, the .mobile version would render. I can also click default, and that will clear out the override and give me back the IE10 user agent string. And now let's try silk. Now I have an override that makes my browser appear as silk, but notice the silk display mode didn't activate. Why is that? Well, it just so happens to be the way that we implemented the context condition when we registered these display modes with the display mode provider. We're going to request.userAgent, which always gives back the true user agent header that the browser sent to the server. If I want to participate and play nicely with this override feature, then I should be using an extension method get overridden user agent here. Again, that's an extension method, so you'll need system.web.webpages here. And we'll do that for both when we're checking for the iPad and checking for silk. Now I should be able to do a build. And let's come back to Internet Explorer, and I'll go to the default view. And we're back to IE10 using the default display mode, and I'll try the silk view. And now silk returns true. Just so happens I didn't have those buttons in the silk view, so there's no way for me to get back. Ideally, I'd have those buttons registered in a partial that I could render from both the silk view and the desktop view, and everything would work out nice. But I want to point out how this feature actually works with the browser. How does the application know on later requests from this browser that we're overriding the user's string? And we can find the answer if I go to the developer tools in Internet Explorer by pressing F12. And let's look under cache and look at view cookie information. And you can see this is the answer right here. The runtime will set a cookie with the name of ASPX browser override whenever you call that set overridden browser method. And that cookie will stick around for this user, so any subsequent requests that they make to the site, they'll still be in the mode that we set. So it doesn't matter how many times I refresh here, because that cookie keeps going back to the server. The runtime is seeing an override for the silk user agent. If I clear the override, that cookie goes away and we'll be back to normal. In this module, we looked at the features added to MVC4 to support mobile devices like smartphones and tablets. We looked at the new mobile template that uses jQuery Mobile, and we saw how display modes can work to let us render custom views. We also created custom display modes and saw how to let a user override their browser settings to view different versions of the site. If you want to see more mobile development with MVC4, see my jQuery Mobile course where I take an existing MVC application, the ASP.NET MVC Music Store, and I add mobile features so that the site looks good on a small smartphone.